Okay, we are going to look at that topic, multivariate approximations. So consider we have a set of data z equal to fxy, and we are going to approximate z with this condition. Number one, x value is in the table, given x is in the table but y is not in the table. Second case is y value is in the table but x is not in the table. Okay, so for these two cases, it's still the simple interpolation problem. And then if we have both x and y are not in the table, so you have a case made now x and y are not in the table, you have to use a multivariate approximations. So for example, one, the power dissipated in a resistor is dependent on the voltage across the resistor. And the power depends on the voltage V and the current I. The relationship between the power dissipated in the resistor P with the voltage across the resistor V and the current flow through the resistor I can be represented as P equal to VI. Here, okay, we have the table. Okay, here the current I varied from 1, 2, 3, 4, and then the voltage 5, 10, 15, 20. And okay, the data 5, 10, 15, 20. Okay, 10, 20, 30, 40, 15, 30, 45, 60, 20, 40, 60, 80 are actually the power dissipated at different current I and the voltage here. And use the table above to estimate the power dissipated. Power is the function of current I and voltage. If voltage across the capacitor V is 10 volt, V is 10, so it's the second row of data here, and the current flow through it is 2.5 ampere. So question A is actually voltage is 10, so you can read it from the second row. Okay, V is constant 10. Okay, current I is varied from 1, 2, 3, 4. Hence you take the second row of data, this will be the Y. Okay, Y is equal to the power when I is a variable, varied from 1, 2, 3, 4. Okay, voltage is fixed, which is 10. So the I 1, 2, 3, 4 is equivalent to the variable X here. So this become and then we are going to estimate P is 10, and then voltage is 2.5. So voltage 2.5 here. We want to estimate voltage 2.5 is at here. Mean voltage 2.5. So what is the value of the power? When current is 2.5, voltage is 10. That's a question A. Question B, voltage across the capacitor V. V is 17 volt. 17 volt. You cannot read directly from the table. 17 volt. Here 17 volt. Current is 3 ampere. So current is 3. Hence question B is actually you can read the column 3 directly. Which is current I is fixed at 3, and then question B is actually Y I is fixed, voltage varied from 5, 10, 15, 20. So voltage is the X here. So we are going to estimate when voltage is 17. So here, voltage 17, what is the V here? Yeah, so voltage 17. So the value should be between here. What's this value? So that's question B. A and B still simple interpolation. Question C, voltage across the capacitor V is 12 volt. V is 12, not in the list directly. Current is 3.5. So for question C, what we are going to do is actually both current I and the voltage V cannot read directly from the table. So the voltage is 12 volt, current is 3.5. Hence, we are going to do, okay, step 1, take first row of data. So interpolate when current is 3.5 while the voltage is fixed 5. Step 2, fix the voltage 10. So take second row of data and then current is 3.5. You get result step 2 here. Step 3, repeat, take third row of data, interpolate when current is 3.5 while the voltage is fixed 15. Okay, step 4, take current is 3.5. Okay, interpolate what is the result here from the fourth row of data. I mean, first step, take first row, second step, second row of data, third step, third row of data, fourth step, take fourth row of data. Okay, after 4 step, you will create arbitrary extra column between 3 and 4, which is 3.5. This result is step 1, step 2, step 3, step 4. Okay, then now you got this data, like, okay, question B, this data, we are, okay, varied from 5, 10, 15, 20. So we are going to estimate when voltage is 17. Okay, what is this one, this value? So the answer should be between step 3 and step 4. So the question C is what we call multivariate approximation. Okay, so we look question A, B, C. Okay, slowly. So I go to the Microsoft Excel. Okay, so the question A, pick up question A. Okay, question A, the voltage, okay, across capacitor V is 10 volt. So mean you can read, okay, directly from second row. Second row, okay, is current is varied from 1, 2, 3, 4. So you have I 0, 1, 2, 3. We take out all data. Okay, and the X is actually the current I. I varied from 1, 2, 3, 4. Okay, and the Y is actually the power, okay, I, and then the voltage is fixed 10. Okay, is 10, 20, 30, 40. So L is a function of the current. So we just need to key in L nodes only. Okay, make sure key in L node correctly. Okay, remember, L node is a function of I, where I minus, okay, I number 1, I minus I2, I minus I3. Okay, divide by I naught minus I1, I naught minus I2, I naught minus I3. Okay, then you key in the I naught formula. Okay, here given I is 2.5, I put it here, 2.5. So okay, I is here and make it as constant so that you copy to the next column. Okay, I remain in the cell C10. So I minus I1 multiply, I can copy the first bracket here. So D, E, F. So they change I1, I2, I3. Okay, and then divide denominator, make sure put a bracket. Select our numerator, Control C, and then you Control V. Select the I, change it back to I node. So I change to I node. So I change to I nodes. Okay, I here change to I nodes. Okay, and then okay, we can quickly obtain L1, L2, L3 by copying slowly one by one. Okay, drag the cell which is outside of the range back to I nodes. Okay, then copy it. Okay, copy to L3. The same technique, provided you copy one by one. Okay, and then this is a power when I is 2.5, voltage is 10. Okay, will be your power when I is 2.5, voltage is 10, is actually your I naught, sorry, L naught, I naught. Yeah, L naught, I naught plus L1, I1 plus L2, I2 plus L3, I3. So L naughts multiply, multiply, this is Y naught plus L1 multiply Y1 plus L3 multiply Y3 plus this L3 multiply Y3. Okay. This is a Y, 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 Y. So you get 25. Is it correct? So it makes sense, okay? 2.5 between 2 and 3, okay, center. So 25. The answer is correct. Okay, and then question B. Voltage across capacitor V is 10 volt. V is 10. V is 17, not in the list. Current is 3 ampere. So it's actually you have third column of the data. Okay, current is 3. So the data actually you can extract from third column, and the data varied is actually voltage. So voltage now is a X. So I can copy this thing, this table, Control C, Control V. So voltage, okay, V is 17. So the X change it to voltage. Voltage varied from 5, 10, 15, 20. Okay, Y is actually, okay, I is 3, voltage is variable. Okay, and then the third column of the data, the last one is 60, 45, 30. Question B, extract the third column, 15, 30. 15, 30, 45, 60. Okay, check. Okay, L now is a function of voltage. In this chain, I change to V. See the same formula. Okay, I you change to V. Okay, then the formula. Okay, but here in at cell C10, you have to drag it, or you don't want to drag, change it here. 18, C18, C18. Okay, here also change it to 18, 18, 18. Okay, this one 18, 18, 18. Okay, 18, 18, 18, 51. Let's check. 25. The second one 51. Correct. Okay. So this is question B. Okay, then I create a copy. So now question C. Question C. Voltage across the capacitor. Okay, where V is 12 volt. 12 volt. So okay, question C. We have total 5 steps. Step 1, we take the first row of data. First row of data, where the X is actually the current, I, where 1, 2, 3, 4, Y, this is a P power, when I is a variable, voltage is phi. So the first row of data, 5, 10, 15, 20. So current is 3.5. Current 3.5. So you get 17.5. Is it correct? So okay, it's look like what we do is here. Now 3.5. Step 1 we get result is here 17.5. 17.5. Okay, and then I'm going to copy, Control C, Control V. So step 2, you just need to change the data to second row, where the voltage is 10. So the data is 10, 20, 30, 40. So okay, so this is the data. Just now this is 3.5. Okay, and the power is 5. Okay, 3.5 power is 5. You get the answer 17.5 here. Okay, this is when current is 3.5, voltage is 10. Okay, we get 35. Is it correct? Makes sense. So this one you obtain the answer 35 here. So you notice, okay, for step 1 to step 4, all the L are the same because the I the same increment. Only the data change. That's why the answer, okay, the power answer will be okay different. The L formula same. This one we delete it. So this is the step 3. Step 3. This is a I. Okay, this is X equal to I. Okay, I is 3.5. P when I is 3.5. Sorry, I is here. Voltage is 15. Third step, take the third row of data, which is 15, 30, 45, 60. Okay. So L is a function of current I. Mm, 45 and 60. Okay, sorry. Current is 1, 2, 3, 4. So you get 52.5. 52.5. Step 3, 52.5, 17.5, 35, 52.5. Correct. Okay. So this is the answer. Power when current is 3.5, voltage is 15. Okay, then we copy it, Control C. Put it. Step 4. Step 4. Okay, this is a power when voltage is 20. So this result is when the voltage is 20. Okay, voltage 20, the result, this is 20. The power is 20, 40, 60, 80. So you get 70. Okay, correct. 17.5, 35, 52.5, 70. 52.5, 70, correct. Okay, so mean after third step, okay, 45 and 60, you get the value. Result for step 2 is 52.5. Last step. Okay, so you see, okay, after 4 step, we create, okay, the column when I is 3.5. So we create this from step 1, step 2, step 3, step 4. So using this 4-step result, we are going to estimate when voltage is 12. So 12 here. So what is the value? So the value is between 35 to 52.5. Okay. Okay, where is it? Then just Control C. Step number 5. Okay, voltage 12. Okay, X now is the voltage. X is the voltage. Okay, Y is actually, okay, here. X is 5 voltage. 5, 10, 15, 20. Okay, and the Y is actually the result from step 1, result in step 2, result in step 3, result in step 4. Okay, then add it back, because just now from here, drag it back, 1, 8, 2, 3. See, given voltage, okay, 12, 24, 24, 24. Okay, this one change also, 24, 24, 24. Okay, or else you can use back that technique, copy, paste, drag back to X node or V node here. Just make sure number 1 correct, yeah, and then you can copy paste, edit it back, drag it back to the first cell. So you get the result is 42. Is it make sense? Okay, not correct. Correct. So between 10 to 15. So the answer between 35 to 52.5. Okay, the last answer 42. Okay, so I repeat. Okay, for question A, voltage across capacitor when V is 10. So it's a second row of data. The Y is a second row of data. Okay, Y is a second row of data. And the X is actually the current. X is current, 1, 2, 3, 4. Y is a second row of data. So Y is a power. When I is a variable, voltage is fixed 10. Then you use the Lagrange interpolation to get your L nodes. So I minus I1, so I minus I2, I minus I3 divided I nodes minus I1, I node minus I2, I node minus I3. And then key in make sure L node correct, copy to here. And then you click the formula of L1, you see those outside of the range, drag it back to X node. And then copy it to L2. Same thing, drag back to X node 2 times, copy to L3, also drag back the cell that outside of the range to X node. And then your P, when I is 2.5, voltage is 10, is actually L node Y node. So L node, see, L node, oh, sorry, here. L node Y node plus L1 times Y1, L2, Y2, L3, Y3. Okay, question B, voltage across capacitor V is 17. 17 is not in the list. Okay, current is 3 ampere. So mean you can extract the third column of data directly. So the third column will be your the green color. The third column is a Y. So third column varied according to the voltage. So voltage will be the X. This. So you can copy the whole table here. Paste, you will change voltage, and then change the data and the formula. Make sure now is given V. V is this cell. So make sure the V cell is correct. You add it to the V cell, and then you may edit the V value one by one, or using the technique copy and edit the formula. Okay, question C is both voltage and current cannot read directly from the table. Because V is 12, not in the list. Current is 3.5, not in the list. So what I'm going to do is actually I'm going to create extra column between 3 and 4, which is 3.5. So to get this result, I will first of all take step 1 is take the first row of data. First row of data. When I put it, let's say first row of data. Yeah. First step, take first row of data. Second step takes second step you take second row of data. First step, the Y is first row of data. Second step, take Y is a Then third step, you take third step. Third row of data. Lastly, the fourth step, the last row of data. The last row of data. You notice, the X is a current 1, 2, 3, 4. X is a current 1, 2, 3, 4. For here, you got 4 row of data. So first step, take first row of data. Second step, take second row of data. Third row, third step, take third row of data. Step 4, take the fourth row of data. So step 1, 2, 3, 4, you have the same I, because it's here I minus I1 times I minus I2 times I minus I3 divided I naught minus I1, I naught minus I3, I2, I naught minus I3 for I naughts. And for each step, the I variation are the same. That's why I are actually the same. So once you get I naught, copy to get I1. Click on the formula I1. Click those who outside of the range. Click back to I naughts. So repeat for I2, I3. And then P, when I is 3.5, this is a first row is a voltage 5. It takes the L naught Y naught plus L1 Y1, L2 Y2 plus L3 Y3. So first step we get 17.5, which is makes sense between 15 and 20. Second step we get, okay, second step you just copy paste, okay, just change it to second row of data. Okay, everything should be automatically calculated. You get the second step, the result is 35, is correct, between 30 and 40. Third step, third row of data, we get 52.5, is inside 45 to 60. Fourth step, we get 70. Okay, and then after fourth step, we create extra column. So this column is varied when voltage 5, 10, 15, 20, and we are going to estimate when V is 12, what is the value, what is the power. So the value should in between 35 to 52.5 here. So here X is a voltage. So the formula, L is a function of voltage. So, so this is a power when voltage is 3.5 from 1 to 3, 4. Lastly, the voltage is, voltage is actually 12. This is 12. Okay, this is why I is, this one I is 3.5. Voltage is a variable. Because you copy paste. Then these are all the result. Okay, this is step 1 result. Then the step 1 result here. Okay, step 2 result. Let's say put it here. This is a step 2 result. Okay, this is a step 3 result here. Okay, lastly, this one is the step 4 result. Step 4 result. So interpolate when V is 12. So the answer should be between 35 to 52.5, get 42. Okay, so with this, thank you for your attentions.